right, so today we're going to cover a couple lessons, 2.1 and 2.2. Both are pretty basic lessons. One about rectangular coordinates, so we'll look at a graph a little bit, and then talk a little bit about circles. A lot of today is just going to be using some formulas and refreshing your memory on some of those formulas that you've seen in the past. One of them is the distance formula. So remember that the distance between 2 points is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. That doesn't really matter which one's x1 and x2 as long as you are consistent when you do the y's. So in this first example, they want us to find the distance between these 2 points. So it, again, doesn't matter which one's rich, really. I guess I'm just going to call this x1 and y1. And we'll call this x2 and y2. And let's see how it plays out. So the distance will equal big square root. I'm going to have a 1 minus negative 2 squared plus, now do it with the y's. You got to start with y2, negative 3 minus 5 squared. Then we're going to simplify inside those parentheses. This is going to become 1 plus 2. That's a 3. And 3 squared is 9. Plus, now we do the second set. This is going to end up negative 8. And negative 8 squared is 64. And then if you add those two together, you can't square root them individually. You have to go ahead and add them together. That's going to end up the square root of 73. Now, sometimes that will reduce. I don't believe it does in this case. Sometimes you might want to go decimal if you're actually trying to approximate something. So you could type it in your calculator. On your homework, you'll just have to pay attention to how they want the answer. If they want it exact or if they round it to some decimal place. So if I was going 2 decimal places, I'd end up there. Which should sort of make sense because this 73 falls somewhere between a square root of 64, which would be an 8, and a square root of 81, which would be a 9. And so that's fallen somewhere in there, making my answer fall between 8 and 9. All right, so looking at a situation, this is kind of some geometry coming back at us using that term collinear. Remember that collinear points lie on a straight line, all right? That's why they are collinear. They lie on a straight line. Now we can use the distance formula to help us determine if points are collinear. What we're really doing is using that segment addition postulate from, or the segment addition property, however it was presented to you from geometry. If the sum of the distance between 2 points, or 2 pairs of points, is equal to the distance between the remaining pair of points, then the points are collinear. So ultimately, what we're saying is that if you have a couple ordered pairs, and they don't have to fall on a horizontal line, but just let's say you have this right here. If the sum of the distances between these 2 points and these 2 points is equal to the sum between these 2 points, the only way that would work is if they fall on this very straight line. If this point was popped up here, then this distance and this distance would not be the same as the full distance there. So we're going to just do a bunch of distance formula. So start way over here on the left, and I'm just going to do PQ. So I'm going to name this PQ. It's equal to big square root. I'm going to do 2 minus negative 1 squared plus, since I started with the 2, I have to start with the negative 4. All right, so PQ is equal to square root of 9 plus, and if you look at this, this is going to be a negative 9 squared. That's an 81. So PQ is equal to the square root of 90. Now, typically, we would break that down. Well, might as well. Let's go ahead and do it. So PQ is equal to 3 root 10. Now what I'm going to do is find another distance from a different set. So instead of going PQ, this time I'm going to use QR. Right, if I do QR, I can start with either point. I guess I'm going to start with negative 10. Negative 10. I'm going to think I'm going to regret this, but that's okay. Negative 10 minus, whoa, 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 whoa. Did you catch that? I was using a y. I need to use the x. So it's going to be a 4 minus 2. That's x minus x squared plus, and now let's do the y's, negative 10 minus negative 4 squared. All right, let's see what that cleans up to. This is a 2 squared. This one over here ends up being a negative 6 squared. So then I end up at the square root of 40, which reduces to 2 root 10. All right, I have one more set. Okay, which ones have I not done yet? P, R. All right, here we go. So I'm going fast. I do R minus the P, so 4 minus negative 1 squared plus negative 10 minus 5 squared. So PR would be, this is going to change into a square root of 25 plus, that's a negative 15 squared, that's 225. So together, that gets me the square root of 250. And if I wanted to break that down, I think I could do that pretty nicely because the square root of 250, I could break that down into 25 and 10. So then I get 5 square root of 10. And then what you're looking at is with these three, you don't always know what order to check them, but ultimately it's going to be the two smaller ones should add up to equal the bigger one. Just like up here, the two smaller distances add up to get you the bigger difference. So I conveniently did the right two. So I've got a 3 root 10 plus a 2 root 10. Oh, what do you know? You get 5 root 10. If that plays out like that, then what you know is yes, they are collinear. All right, I'm not going to do a bunch of examples with each formula because I know you've seen these before. I try to just do it like maybe one or two of different, maybe more difficult types. Midpoint formula. Okay, so to me, when I'm doing the midpoint between two things, I've got these 2 points that I'm trying to find the midpoint. To me, what I'm doing is I'm just finding the middle or the average of them. So if you think of it like you're finding the average between two numbers, well, you would just add them and divide by 2. Well, that's what we're doing, but we're doing it with x's and y's. So the midpoint formula is equal to, now I'm going to find the average of the x's, so that means I'm going to take x1 and add it to x2 and divide it by 2. Notice that's different than our slope formula. Our slope formula has a minus sign. The distance formula had a minus sign. This is the one that has a plus. Now do the same thing with your y's. y1 plus y2 divided by 2. So there's your midpoint formula. This first example, pretty straightforward. Just find the midpoint between these two. So that I would do an M because I'm labeling my midpoint as point M. We will add the x's together, divide by 2. Add the y's together, divide by 2. So this first point gets me a negative 1 over 2. And this other one gets me a 2 over 2, which I would reduce to just a 1. This is the little a little bit more challenging use of that midpoint formula. It's when you already know the midpoint and what you're looking for is a different endpoint. So it says use the midpoint formula to find the coordinates of the other endpoint of a line segment with one endpoint at -6, 12, and I actually already know the midpoint is 8, -2. All right, so what I'm looking for is some other point. I guess I'm going to call it point. If I called this first one point A, then this would be a point B, let's say. And I'm just going to call it X comma Y because that's what I'm searching for. Well, I kind of do the same thing as I did before. If I know the two endpoints, I add them and divide by 2 to get the midpoint. So that's what I'm going to do. I'm going to do it with the x's first. I'm going to add the x's, divide by 2. I should end up at 8. So let's give it a shot. Here we go. -6 plus x divided by 2. But here's the deal, is it's not just this, but I actually know what I'm supposed to get from doing this. When I take this x plus this x, divide by 2, I'm hoping to get the midpoint. So this right here should equal 8. Likewise, I can do it with the y's. I should be able to take 12 plus, I don't know what the other y is, but when I divide it by 2, I should get the y value of my midpoint, which is a -2. Then you just do a little bit of solving. Add 6 over, so I get x to be 22. And then over here, multiply both sides by the 2 as well. Subtract the 12. So y is -16. So what I have found is the other endpoint. Make sure you write it as an endpoint. So it's going to be 22, -16 is the other endpoint between these two. All right, one more application of where you could use the midpoint formula says in the United States, fast food restaurants sales increased from, we have 167.7 billion in 2011, and then in 2030, or $233.7 billion in 2017. So it says use the midpoint. So what's going on here is that if you were to think of it like it was a graph, you'd have some value here in 2011, but then it increased in 2017. And what they're asking for is to estimate 2014, which is conveniently the midpoint between 2011 and 2017. So what I'm going to do is go ahead and look at these as if they were ordered pairs. So if I look at, usually use time as your X value. So I'm going to look at it as a 2011, and then I'm going to call it just 167.7, but know that it's in billions. The other ordered pair that I have is 2017, and then I get 233.7 billions of sales. Okay. Now, using that, I'm going to find this midpoint value, this 2014. So remember, you're finding the average, so you're just going to add and divide by 2. So I get 2011 plus 2017, add the x's, divide by 2. Now let's do the y's. Add the y's, divide by 2. All right, so then you can go to your calculator to simplify this up. 2011 plus 2017 divided by 2 is the 214, or I'm sorry, 2014 that we wanted. All right, this is not quite as pretty, 167.7. I'm just typing this in right now, adding those together, dividing it by 2, and I get 200.7, and that would be billions of dollars in sales. And then what they want us to do, they want to compare it to the actual figure of 195.4 billion. So what do you think? If I were to go Google it, here it is, 195.4 billion versus this is what my math got me, 200.7 billion. Okay, so if I were to compare those, I guess what I notice is, well, they're not the same. And my prediction is a little higher than what it really is supposed to be. And since I found the mathematical midpoint right here, that is truly the midpoint between these two endpoints that were given. Well, if this is the 200.7 and it was really 195, so this is actually plotted a little high. It would be like right here. Got my dots getting kind of big, but it'd be just a little bit lower than that, meaning that it doesn't really fall in a nice, perfect linear pattern. All right. Let's see. Estimate the sales. Okay, I just wanted to make sure that I answered the question accurately. So, all right, so what I'm looking at, what they wanted to know is what estimate the sales, and I've got it right here. These are the sales. So I would write 200, and it's money, so I'm going to do 200.7. Remember, it's in billions. That would be my estimate of what the fast food restaurant sales would have been in 2014. All right, we're going to move on to circles. And the equation of a circle actually comes from the distance formula. So that's why they put it in here. The equation of a circle actually looks a lot like the distance formula. It is going to be x minus h squared plus y minus k squared equals r squared. All right, now, what does that mean? Well, x and y are just a couple of points that would fall on the circle itself, but the hk, if you think about what you're familiar with this doing, is that this h would move it left and right, and you would always do the opposite of what that sign is. Same deal. And this is also the case. I would do it with the y. Do the opposite of what you see here. If it's a -4, then I'm going to use a +4, that kind of thing. And what the H and K are telling me are the center of my circle. And what do you suppose the R stands for? Yep, that is the radius. All right, so let's see if we can use that information to write an equation. So this says, write the equation of a circle with, and they tell me the center and radius. You're just popping them in there for the H, the K, and the R. So it would be X, and it would be a minus -3, so I'm going to change it to a +3 squared. And then the formula in the middle has a plus sign. And let's do it again. It's going to be a y minus, and now this is the y value of the center, which is a 4. So it's y minus 4 squared equals the radius squared. So 6 squared would be 36. So there's not a whole lot of work to show there. You're just putting that info in the right spot. Next one, just a little bit quirky. It's supposed to actually look nicer, but sometimes when you get that 0, it starts to look weird. So what I want you to recognize is if you have a 0 for your center, don't complicate the formula. I would put 0 in for h, so it would be x minus 0 squared. Well, that's just x squared. So be sure to take advantage of that. It's supposed to give you a shortcut. So it's going to be an x minus 0 squared, or just x squared, plus, now this time the y does have something with it, so here we go. It's going to be a y minus that y value squared equals the radius squared, which would be 16. Okay, there we go. Actually, these equations of circles make it really super easy to graph also. So let's just practice a little bit of graphing. So here's the equation of some particular circle, and I can pick out all the key points. I can look at this and say that the center would be, and I'm looking right here and here. Now the formula is naturally supposed to be a minus, so I know the y value is a 2. Since this is a plus, it must have been minus a negative. So the center is going to be at a -3 and a +2. And the radius comes from over here. This is r squared, so I square root it to go find the radius. And there we go. So now what you're going to do is just plot the center, left 3, up 2. And then if the radius is 6, that means you can go in all directions, go out 6, and it'll be a dot on the circle. I'm just going to pick the key ones. I'm going to go to the right 6. I'm going to go to the left 6. I'm going to go up 6. And I'm going to go down 6. And with those 4 points, I just try to do my best to make a circle out of that. So make it nice and round. It's not a square. It's not a rhombus. Try to make it nice and round. Okay, look at the next example here. What's weird? Oh, I say weird. I don't know. It's ideal, really. There's no parentheses. There's nothing going on like there is over here. Well, what that means is this h and this k must have been zeros. And that's how I ended up with just an x squared and just a y squared. So that means a problem like this, it's centered at the origin at 0, 0. Okay, the other thing that I gave you here that is not quite as ideal is I gave you a number over here that is not a perfect square. This is supposed to be r squared. So if r squared is equal to 12, then r would be equal to, well, we could do the plus or minus, but it doesn't really, you can't have a negative radius. So all I'm really going to do is estimate this. I don't really want you to break it down to a 2√3. Just think about a square root of 12. 12 is not a perfect square, but it falls nicely between two perfect squares, 9 and 16. So that means that the square root of 12 is going to fall somewhere between a 3 and a 4. So I'm just estimating this. The graph is so tiny, I'm not going to be able to get it any more perfect than what I'm going to do. So then I'm going to go right 3, or a little bit on each one of these, up and down 3 and a little bit. And then just make my nice circle. Oh, that was not what I meant to do. I moved my point. Let's try that again. Oh, that's pretty good. Okay. All right, one last thing. Here's a couple harder problems and we're going to tie together the equation of the circle with those other formulas that we were talking about earlier. I'm just trying to write that equation. And so in order to write the equation, I have to know the center and I got to know the radius. The center is going to be an ordered pair, but the radius is a length. So on this first one, I got a couple examples. It tells me where the center is. Awesome. If they tell me where the center is, I automatically know this is my H, this is my K. But they didn't tell me the radius. Instead, what they told me was another point on that circle. Well, think about it for just a second. I'm just going to sketch a little picture here. If I went left 16, down 9, let's say it's right here. Then I went left 17, down 10, like this. Well, this is ultimately, if that dot is on the circle looks like this. And so what I could do is I could do the distance between these 2 points, and that distance would be my radius. All right, so here's what I'm going to do. I'm going to go find, I already know the H and the K. I need to find the radius. So let's make a little note so we know when we come back and look in our notes. The radius, I'm going to do the distance between these two. So distance equals big square root. I'm going to do x minus x. So just to show you that it doesn't really matter which order, I'm going to start with the negative 16 this time. So negative 16. And then you're going to subtract the other x. So subtract negative 17 and squared. It looks like a 77. So let me fix it. It's going to be plus plus there. Ooh, still don't love it. It's a plus 17 right there. Okay, okay. Keep that square root thing extended out here until you get to the end. And now I'm going to do the same thing with my y. So let's add the y's. You got to do it in the same order. Negative minus negative 10 squared. This is going to play out nice because that's going to get me a negative 9 plus 10. That's just a 1, and 1 squared is 1. And over here, I got the same deal. Negative 16 plus 17, that's a 1. 1 squared is 1. So I'm going to land at the square root of 2 for my radius. And then I also know the h and k. So now we're just going to go write the equation. You can peek back, or hopefully you're starting to get the hang of it. It's an x minus the h, so that's going to turn into a plus 16 squared, plus, now we try it with the y's. It's going to be a y minus negative 9, but that's a plus 9 squared, and it equals the radius squared. So if I take the square root of 2 and square it, I'm just going to get 2. And that, ladies and gentlemen, is the equation of the circle they want. Okay, next one. Let's star this next one. I'm going to even change colors so this stands out a little bit from the other example. This is a little bit harder and definitely one you're going to see on your test. So this time what I'm giving you are the endpoints of a diameter. Remember that a diameter is going all the way across. Ooh, that's not very good. Let me redo that. It's going all the way across the circle. That's not a lot better. But if they give me this point and they give me this point, I should be able to figure out the center and the radius. Let's start with the center. What do you think you need to do to find the center? Well, it would be right here. So we should use the midpoint formula to find the center. All right, let's go ahead and do it. Remember, the midpoint is like finding the average. So you're just going to add the x's, divide by 2. So it's 9 plus negative 11, divide by 2. Now you do the same thing with the y's, 0 plus 2, and divide it by 2. So the center is going to end up being, it looks like negative 2 over 2, so negative 1. And then 2 over 2 is a 1. All right, that's a pretty nice little center. So now you know your h and your k. But now we also have to find the radius. And the radius, now that you know the center, we can use this center and either one of those points and do a distance formula to find the radius. I don't want to do the distance between this and divide by 2 because sometimes it won't divide by 2 very nicely because it's going to have like a radical or something like up here. And so don't choose the endpoints that are given. To find the radius, use the distance formula. With the center that you recently found and one of the endpoints. And you get to pick on the endpoints which one you like better. I got to think the one with the 0 seems like it's going to be easier. So I'm going to use the 9, 0. And I'm going to use the center, the negative 1, 1. So here we go. I'm going to do distance formula. I'm going to go ahead and rewrite these so that you have them so you know what you were doing. So distance is going to equal big square root. And we're going to do x minus x. So I'll do 9 minus negative 1 squared plus, and then my next one's going to be the y's, 0 minus 1 squared. Okay, looks like the distance is going to be, that's a plus plus, so that's a 100 plus, this is going to end up in -1 squared, which is a 1. So I end up with a length of square root of 101, which is just, oops, which is just a little bit bigger than a 10. Now I put D, you know what I really should have put is should have put like an R right here for radius instead of a D for distance. This is telling me what the radius is going to be. Now, even if this square root of 101 would reduce, I don't really want to reduce it because in the formula, I'm going to turn around and square it. So it's easiest just to leave it as it is. And now I'm ready to write my formula. It's going to be an x plus 1 squared plus y minus 1 squared, just using my center over here, equals, and it's the square root of 101 squared, which just gets me 101. Okay, so definitely some more work on these problems. Try to keep it organized so you can track it and so that I can track it. All right. Good luck.